Hello everybody, I'm back again for another video. It's going to be the same integral 1 over x to the 5th plus x cubed, except this time I'm going to use substitution. So I'll do the same first step where I just where I factor out the denominator into x cubed times x squared plus 1. But I'm going to switch the order of these two, 1 plus x squared. Hopefully you guys don't mind that. And so I did a substitution where you let u equal the arctangent of x. And for those of you who can't see why, I'm going to differentiate both sides, so you get du is equal to 1 over 1 plus x squared dx. And so when you look here, you can notice you have a 1 over 1 plus x squared dx right here. And so this will equal the integral of the 1 over 1 plus x squared dx is just du, and you still have the 1 over x cubed, so you have to figure out what x cubed is. Well, if you, let me just change the color to blue wasn't very visible in the last video, so I'm going to use green. If you take the tangent of both sides, you're going to get that x is equal to tangent u. So x cubed is going to be tangent cubed of u, and so this is going to equal the integral of tangent. 1 over tangent is the same as cotangent, and cotangent is the same as cosine over sine. So it's going to be cosine u over sine u. But remember, this was tangent cubed u, so we have to carry the power over to both of these. And you still have the du, which is in white, not green. And let me just separate this so it shows that this is not part of it. Alright, so now let me go down a little bit. So we could split the cosine cubed up. I'll split it into cosine squared times just the normal cosine, because you could add up the powers, it'll be equivalent. So cosine squared u times, I'll put this in white, cosine u du, and then it's still over the sine cubed du. And so now I'm going to use a trig identity here, so you know that sine squared, I'll put it up here. Whoa, what just happened? Now what we're going to do is I'm going to use a trig identity here. So cosine squared, I'm going to put it right here actually. So you know that sine squared x plus cosine squared x is equal to 1. That would mean that when you subtract sine squared x from both sides, you're going to get that cosine squared x is equal to 1 minus sine squared x. And so we're going to use this trig identity right here to substitute 1 minus sine squared x in for cosine squared x. So you're going to get here 1 minus sine squared x, and you still have the cosine x, or oh wait, no, it's not x, sorry, it is still u, and then it's still times cosine u du over the sine cubed of u. And so now I'm going to do another substitution here. So what I'm going to do is I'm going to put this in light blue. I'm going to let t equal sine u, so that dt is equal to cosine of u du. And so then this will equal the integral of, this is 1 minus sine squared, that's just the same as saying 1 minus t squared, and then the cosine u du is just dt. This part right here is just equal to dt. And so then this part is still divided by the sine cubed of u, and so that's just going to be equal to t cubed. And so this one we could just, this is pretty easy to solve. We could just split the fraction here, so you get the integral of, you're going to get 1 over t cubed minus t squared over t cubed, which is the same as saying 1 over t, and you still have the dt, and then this will just be the integral of 1 over t cubed is the same as saying t to the negative 3 power, and I still have the minus 1 over t dt. And so I'm going to scroll down a little bit more, and I'll evaluate the rest of this here. So the integral of t to the negative 3 is the same as t to the negative 2. Let me keep the colors consistent. T to the negative 2 over negative 2. And then minus the integral of 1 over t is just the natural log of the absolute value of t. And so now I will substitute back in for t. If you remember, the substitution for t was t equals sine of u. So that means that this is going to be sine of u to the negative 2 over negative 2, and then minus ln the absolute value of sine of u. And so now, if you remember, we are still not done because we still substitute back in for u. So we know that u, if you scroll back up, is equal to the arctangent of x. So let's put that back in. So this is going to be, and while I'm at it, I'm also going to move the power to the denominator. And so it's going to be negative 1 over 2. I just took this negative sign right here and moved it to the top. So anyways, this is negative 1 over 2 times the sine squared of the arctangent of u, of x, I mean actually. And then now we have minus ln the absolute value of sine of the arctangent of x. And so now we are done with this, so we can put the plus c and box our answer. So if you remember in the last video, we had a different answer for this integral. We didn't have trigonometry included in here, and so you may ask, are these the same answers? And the answer is actually yes. The only difference is that the two expressions that are the answers, they differ by a constant. So this plus c right here, this c right here is different from the c in the previous video. And so, yeah, technically, yeah, this is still right. So that's it for part 2. I hope you guys enjoyed this very different method. And if you enjoyed, like the video and comment what you'd like to see next, and I'll see if I can do it. Anyways, this is it, and I hope you enjoyed. Take care.